and it's my pleasure to welcome you to today's session. Before we get started, I just wanted to welcome everyone across Zoom, across LinkedIn. We're streaming live, and I just wanted to run through a few housekeeping items. So you can ask questions. We've allocated time at the end to address any questions. We've also got Matisse and Tyler on hand to take questions as we're going through. So please feel free to post those questions as they come up. The session is being recorded, so you'll be able to access it on demand. And just to make sure you can see everything that's going on, in your Zoom webinar panel, you can see either the general webinar or follow my screen or the presenter screen in that top bar to make sure that you can see the presentation slides that are being presented today. Before handing over, I just want to introduce a little bit around SODA. Our mission is simple. We want to empower everyone in your organization to be able to share and use high quality data. And that mission starts with trust in the data. So for all the things that your organization uses Databricks to achieve, and we'll be seeing some of that today, whether that's fueling machine learning models or creating downstream reports, or supporting decision-making, none of that will really work without reliable data. So every pipeline, every model, and every report is only as good as the quality of the data that it's built on. So today, the team are going to be showing you how to check and ensure that data quality in your pipelines so that the data that matters most to the business is trusted, it's accurate, and it's actionable. And it's important to remember that this isn't just a job for engineers. Business and engineering need to work together. And both sides need that visibility and alignment. And I'm hoping the showcase that we've put together will show you how you can ensure that and enable that. So without further ado, let's dive in. I'm now going to hand you over to your hosts, Vivi and Hazem, and let them take control. Vivi, the floor is yours.
Awesome. Thanks a lot, Taz, and thanks everybody for participating in our webinar today. So just some logistical things. I'm Vivi, of course, one of the presenters today, and together with me I have Hazem. We're both working in customer engineering at SODA, and we come from a background in the space of data. Today we will encapsulate two different personas that both of us are going to leverage SODA in two different ways to be able to collaborate and define our data quality strategy in our organization. So I will be more of a technical persona, so we can imagine like a data engineer or a data scientist within the organization. And then later on, Hazem is going to take the floor and show us how also a business user can actually write their checks using SODA, and in more particular within SODA Cloud. Let me quickly go to the next one. So for the people already familiar with the product, just bear with us for a couple of minutes. I think it's important that we mention some of the most let's say, focal points around the tool, as well as where we fit in the current ecosystem, also for the new joiners that would like to meet the product in more detail. So starting from the product capabilities, where do we focus at the moment? We have data observability, which is a feature we will not really dive into detail today, but basically, SODA is monitoring your data in production in an automated way. And then we make sure that we bring insights about specific information around your data, as well as we keep historical track of specific information around data quality dimensions, and then apply an anomaly detection algorithm on top of this that essentially allow us to spot potential outliers or changes in the trends and patterns of your data. In terms of more of a business use case, basically within SODA, we offer a unique collaboration space where different stakeholders can actually work together in defining their strategy. So we imagine that people that carry a lot of domain knowledge, but not necessarily have all the technical skills required, for example, to do things as code, they can actually contribute by being self-served within SODA platform. They are able to write their own checks in a no-code environment, just in a few clicks, or in a low-code environment in SQL. And as well, they can also open discussions with other stakeholders, all of that with the support of SODA AI that we can spot in different parts within the solution. If we take a step back, SODA focuses actually more on the prevention of things. So we basically want to encourage data engineers to test as early as possible within their data pipelines and as often as their data requires. So basically, you can leverage our Soda library that is Python-based, as well as Soda CL, which is our check language that is YAML-based, and we will see a couple of examples later on, to embed tests in different steps of your pipelines, or even before during your CI/CD development, ensuring that you catch problems before they actually flow down the stream and prevent potential problems when they occur. The last focal point is around operational data quality. So basically, we gather diagnostics around all this important information, and then we'll make sure that we notify the right people that need to take action further upon. Moving forward to where Soda fits in the current ecosystem. So as we see, more or less, Soda sits right in the middle. Basically, it's a SaaS platform that it's SOC 2 compliant. And the way that it interacts with your data is via a component called Soda Agent that by default is hosted by us and given to you as a service. But in the case that your data is behind a private network or is highly sensitive, you always have the possibility of self-hosting the agent within your own cloud infrastructure, with the only requirement being Kubernetes. In terms of compatibility with data sources, of course, the primary focus today is Databricks, which is fully supported. But good to mention that we also support all the cloud solutions, as well as, of course, Databricks and Snowflake, some of more legacy databases. And by leveraging our connectors via Spark, Pandas, or Dask, you are actually able to perform checks on top of files that reside somewhere within your data lakes, your Databricks file system, or even locally. Soda uses a push-down architecture, which means that all of the rules you want to apply to your data are essentially translated in optimized SQL queries, and then they are executed into your system. The requests are inbound, so you can configure that in a way that no data leaves your environment apart from aggregated metrics and metadata. In terms of orchestration, today we will see an example, of course, of a Databricks workflow, but essentially anything that can run Python or Bash can also run Soda. So now we're at the step that we have defined our checks and we have scheduled them and executed them against our data. So now we have the results of that. And if we move a bit to the right side of the presentation, we have a lot of possibilities on how we can proceed afterwards. In the simplest format, of course, we would like to be notified in the case something is going wrong. So Soda is going to send emails to the right recipients and let them know that potential problems have been detected. Of course, if you're using communication channels within the organization, like Slack or Teams, you can actually integrate that with Soda and then receive live updates in the relevant channels. Soda has already in-house an incident management solution where basically whenever you spot an issue, you can actually open, let's say, an incident in the cloud. But of course, if you're using something in-house like Jira or ServiceNow, via webhooks, you can actually integrate that with Soda, and then you can make those two systems synchronize and update at the same time for better ticketing management. One more thing is that within the solution, there is a visualization that basically gives you an overview of what is happening around your data quality over time. So on a daily basis, you see how many checks are passing or failing, for example. But in the case you want something more tailor-made or organization-specific, you can always leverage our cloud API, extract all of the information outside of Soda, feed it, like save it back into your system, and then feed your BI solution on top of that. So then you can, of course, create something in, let's say, Looker, Tableau, Power BI, or of course, as we have today in our webinar, within a Unity dashboard as well. The last thing is that Soda integrates with the list of data catalogs out there, where we basically push information around the health of your data, what are potential problems that are detected, supporting you further on with your data governance, and then ensuring that your data stewards and business users are always aware if your data is safe for consumption. So without further ado, let's actually dive into the problem of today. So we will see how we can test our data quality within our Databricks pipeline. Let's begin with our problem statement. So it's a very simple concept, but I think it occurs more often than we believe. So we have our HR department coming to our engineering department, and they basically tell us, okay, we would like to develop a model to make sure that we know or we get, let's say, notified when somebody might leave the organization in the X period of time. So we basically want to build an employee attrition model. The objective is very clear. We just want to predict the likelihood of that happening in order to basically support the retention strategies. The business impact is also very big, because basically when people leave a company, we have a lot of costs around recruitment, training of new employees. And of course, after all, we always want to retain talented people. And let's be honest, nobody really likes changes all the time. Without focusing on all the, let's say, requirements and then how we select the model, because it's not really the scope of the webinar today, we will basically see how we can face challenges around data quality and how can we ensure that good quality data flow down our pipelines, or that we basically try to reduce the impact in the case we find a potential problem. So moving forward to the agenda, we will basically see today how we can write SODA-CL checks in different steps of our pipelines, how we can invoke SODA within a Databricks notebook, how we'll check the results back in SODA Cloud, and we can set up notification rules as well as create incidents on potential problems. And then Hazem is going to show us how you can leverage the UI and write checks in a no-code environment. We will see how we can centralize all of this information and collaborate between personas, and then, of course, review all of those results in a Unity dashboard. Last slide, and then we'll dive right into Databricks. So basically, just to have an overview of our pipeline within Databricks. So it all starts, of course, by ingesting certain data sets. We have information, let's say, around our employees, like demographical data, which is a bit of more stale data. And then we have, for example, survey information that is updated frequently, both for managers and employees, as well as performance information that it's also updated on a frequent basis. Afterwards, we essentially want to start by embedding SODA checks to ensure that the ingestion has happened successfully. This is more of, let's say, a responsibility or a task of a data engineer, but of course, within an organization, there also can be overlapping. So this is also something a data scientist might do, for example. So essentially, you would like to check for certain quality dimensions. You want to ensure that your data is complete, unique, it's fresh, that all the information is there and complies to certain validity rules. Afterwards, and once you ensure that all of your standards are actually compliant with your data, you can move forward in basically transforming all this information in an input that is compatible with what you would like to put into your machine learning model. So after the transformation notebook, you apply a new set of rules that either your data scientists can do their own, or they can even define the rules they would like to apply, and then the data engineers can actually enforce them. This means that basically you ensure that the transformation has happened in a way that is successful and you don't have any unexpected values before actually use this information to train your machine learning model, which of course, it's very important to actually maintain and be sure that good quality is flowing down the stream, not only because basically bad data is going to produce unexpected results, but also nowadays training a machine learning model can be very costly as well as heavy computationally. Afterwards, we apply another set of rules just to basically keep track of certain performance metrics of our model and KPIs we have defined. And then we have two more tasks of extracting this information to Unity, and we'll need a dashboard on top of that to be able to inspect whatever is happening, as well as we review all of the checks back in SODA Cloud. So from here on, I will basically go right into Databricks. So let me quickly share my screen. I believe my screen now is visible, correct?
We can see your screen.
Yes. Awesome, perfect. So we are within the environment of Databricks, and I can actually go into my workflows where I find my pipeline about my employee attrition. I can click from here, and then if I go under tasks, I basically see exactly all of the steps that we have described in the slide, of course. So we have certain ingestion, we perform a few checks. We later on move forward into transforming all of that in a single table that we will later on use as input to train our machine learning model. We apply a set of rules right before training our model to ensure transformation was successful. And after we train our model, we actually perform a new rule of sets, and then we finish by exporting all this metadata to Unity. So as you see in this pipeline, we essentially embed tests in 3 steps after every basic task. All of those steps are actually Databricks notebooks that we're actually going to see right away an example of that. So let's say for this specific one about the input data checks, if I go into my notebooks, I can actually inspect exactly how this looks like. The first thing is that we want to install the right packages. And in this case, since we're performing a check on top of a table that lives within our Unity catalog, we basically want to install Soda Spark Databricks. And then after certain more processes, we restart the notebook, we import a few more relevant libraries. And basically from here, this is where the Soda magic begins. So we initiate a scan object, and then we define a name for this scan. In the terminology of Soda, a scan essentially is the process that is going to execute all of those rules against our data. So we're defining the standards of that, and then within the scan, we ensure that the data complies with the standards that we have set. We set up a data source name and then attach a Spark session. All of this information here around the scan definition as well as the data source name is also going to be later on available within Soda Cloud. We continue later on by configuring our data source as well as our Soda Cloud. And basically here, we pass information, of course, around our data source, what type it is, what is the schema we would like to actually leverage, as well as our credentials, which in this case, we use environmental variables for. And then we also add our API keys of Soda to be able to push all of this information back in the cloud. Of course, this configuration can also reside separately in a YAML file and then just be referenced within the notebook, but we just have it hard-coded here for purposes of the webinar. The next thing, which is optional, but it's a step that we take in this example, is that basically we add template files to our scan object. And without going into depth, basically a template within Soda is a reusable piece of code. So whenever you find yourself adding the same check multiple times, you can actually create a template out of that, and you can leverage that whenever you need to execute this specific check against your data without having to rewrite everything from scratch. The last thing that we add is our actual Soda CL checks to our scan object. So let's go immediately and see how this would look like. We're keeping the checks in a separate YAML file outside of the notebook. Of course, it could also be defined within the notebook, but having that stored separately also allows you for better management as well as version control. So at the beginning, we have some optional configurations where we basically decide which data sets we would like to include in the solution coming out from the schema. So we decide on including everything and then exclude a couple of those tables. And then as well, the same thing for the profiling information. Scrolling a bit down below, we see that we basically define a filter for this specific table that acts as a partition. So in this case, our data is always lagging one day, and this is why we define a daily filter. But essentially, within Soda, a filter can be anything that you would like to segment your data on. So then later on, you can apply these rules only in this specific segment of data. We continue by actually defining our checks for this specific table, starting from those two checks that we referenced within our templates. So this is why they start with a $sign and they follow a bit of a different syntax than Soda CL, but we basically just pass certain parameters since it's a template we already have defined. But if I scroll a bit below, we actually see more of the normal Soda CL syntax. So we have checks around invalid percentages. We do a reference check to ensure integrity between tables. We also have a custom SQL query because, of course, Soda offers a lot of possibilities out of the box that you can leverage. But in the case you have something very custom, you can actually always write your own SQL and then use the failed rows check to be able to leverage that within the solution. And here, instead of actually hard coding values, you can even use variables for further scalability of your code. We continue by applying a freshness check to our data. And then below, we have two checks, so group evolution and group by, which are part of more advanced checks, let's say, and they're only available in the commercial version of Soda, alongside with reconciliation checks and anomaly detection checks. So what we see here is that we're testing that there's no change in our groups, No specific group is always required, so it's always present in our data. And then we also have a group by check. Within SODA, we can basically define an alert, a distinction between a warning and failure for when we would like to be alerted. So as you can see in this example here, on a check level, we can basically design those two different thresholds, but it can either be absolute or relative ones, as in this specific case. Of course, a good practice is that we always give a name to our check. And then the last thing that it's very important in the concept of SODA, even though it's actually optional, is that we can add an attribute in our check when we define them either as code, like in this example, or later on as no code, we can also do the same thing. An attribute is essentially a variable that we define within SODA Cloud. And basically it works in two ways. The one thing is that it's tagging our check with extra information and metadata. And the other thing is that later on, we can actually leverage this value to create filters for different purposes, like, for example, setting up a notification rule that is based on specific checks, as well as use that as a filter to find back specific checks or even for our visualizations. Once we've set up our SODA CL checks in our separate YAML file, I can go back into my notebook where I basically execute the scan, and I can already see some of the results within Databricks. So we already see that we have 4 checks passing only out of the 13 ones that we have defined, and all the rest have been failing, which of course is not a very desired result, let's say. If I scroll a bit more below, as we see, SODA allows you to add an assert statement that basically is going to circuit break your pipeline. So in this case, since we have checks that are failing, the list of the things we would like to do is to continue the pipeline and then train our model on this bad data. So from here, by adding this statement, my pipelines are actually going to fail without processing to the next task. If I go back into my pipeline and in my last run, for example, as you can see, since this step has failed, nothing down the stream has followed. I can, of course, expand from here, and I can inspect already within Databricks what has happened. So I see a couple of checks that have been failing. But of course, if I want a more user-friendly interface and more capabilities, I directly go into SODA Cloud. So from here, I can go into my data sets, and then I can select my employees data source, which is the one that we have defined within Databricks, and I can see all the tables I have onboarded within the solution. I can select the specific one that we've been working on, and I have set all of these, all of the input data checks essentially around, and I can see exactly within SODA what is happening around the problems that we have identified. So of course, on top, I see some basic KPIs, like on how many checks I have around the specific table, what is the overall health over the past days, as well as if I had an incident open within the solution, I'm actually able to see that in my incident calendar. From here, I can select any of those checks. And as you can see, I go into a tab that basically shows me the check history. This means that we have a point in time that this notebook has been executed, and these are the results. So this is a problem that apparently has been raising for a while now, and we never were able to take action upon. So I can click on any point in time, and I can actually see the aggregated metric of how many records have failed. Of course, SODA offers you the possibility of the failed rows analysis. So I can select actually any point in time, and then I can click below the failed rows analysis, which will basically show me all of the problematical records. From here, SODA is trying to give you an indication of how you can continue with further fixing the problem in your data. So we'll provide you with a set of failing records. But of course, in the case you don't want to expose this information within the cloud, you always have the possibility of disabling this feature. And you will see a banner that says that the failed rows are stored externally. And then you can get the SQL query that is executed in the background, which we can also get from here in the 3 dots, copy paste that into your environment and get the full set of failing records. Another option for failed rows management is that you can basically, during your pipelines, you can actually decide to reroute all of these records back into your system. So either store them in a temporary table, for example, or even save that in a file somewhere within your file storage, and then continue further root cause analysis from there. And here, when you enter Soda Cloud, you will basically see a banner saying that these failing records are stored externally, and potentially a link you can follow to find them back. So now we've seen, of course, that we have these checks that they have been failing, and I'm aware that my pipeline, for example, has stopped. But I can further on actually receive alerts that something is going back by defining a notification role within Soda. So from my icon here, I can select notification rules. I have already set up a specific notification rule for this use case. So let's go ahead and see that in more detail. Of course, we start by giving a descriptive name, and then we can decide between all checks or specific checks, for example. So in this case, I'm actually using specific checks. And then I'm leveraging below the attributes feature. So here, I'm actually deciding which attributes are important for me to specify this notification rule. I select my team, which is data science, and then my pipeline stage, which is the transformation step. And then below, I can decide between recipients, which means that I can actually send that to a user, to a group of people, or even a communication channel, like in this case, that I have sent that in a Slack channel, which is a very common case within the engineering world, that you basically have one channel to monitor all of your pipelines. So we basically have the same concept here. And then you can decide which alert you would like to receive. So do you want to receive notifications for all the results, even in the case there are no problems, just to ensure that everything is okay? Do you want to only receive failures, or both warnings and failures in this case? Since this already have run and has failed in the background, I can actually show you very quickly how this would look like on Slack. So let me just quickly move here my window. So basically, as you can see, I received a notification that shows me that my table name, as well as the time that my pipeline has been executed and it actually had problems and failed, as well as all the checks that have been problematic. So what are the problems detected into my data? So from here, I can actually click on view results, and then I can always be redirected back in Soda to take further action. Last thing I would like to show you is that since now we are notified, of course, something is not going well. So we come into Soda Cloud, we inspect, indeed, there is a problem with our data that has not been fixed. We want to take further action upon that. What we can do is that we can actually decide to open an incident from Soda. So I can go ahead in a failing check, and I can create an incident. I can allocate a severity, and then I can say that I can put a title over time is detected, for example, and then a description, like something just for the webinar. So this is gonna basically open a new incident under my incidents tab. As you can see, certain information is pre-filled already. So I am the reporter of that. I can assign that either to myself or to another colleague within my organization to have a look into this. I can add more description. And then we have 4 statuses within Soda, depending in which level of debugging you are at the moment. Very important to mention is that, as you can see here on the right side, if you have basically integrations with third-party tools, you are actually receiving live updates. So in that specific case, I already have a Slack channel that has been created about this incident, where I can receive live updates on what is happening. The same thing for Teams. And in the case you also use a ticketing management system and you have integrated that with Soda, it will basically open a new ticket into your board. So this is an integration via webhooks, which means that you can basically map different values from Soda to be able to map with the values within your management system. And as you can see, for example, we have the name of the check that has been failing. We have a URL that we can follow that always redirects us back into Soda Cloud. We have the check name that has been failing, and also the assignee. That is me in this case. So I can actually keep better ticketing management system in both tools, and this can be bilateral. So you can update one of the tools and then the other one will also be up to date. So from here, we've seen how we can actually perform tests within our pipelines, how we can actually stop our pipelines, depending, of course, on the operational model, and then inspect the results back in Soda Cloud, how we can set up notification rules that are meaningful and that allow us basically to keep track of all this information and be always on time, and then how we can also create incidents from within Soda that will also be depicted in our own ticketing management system. So now we'll take a pause here, and I will give the floor to my HR analyst, Hazam, who is going to show us how we can leverage the UI and actually, in his own use case, how he can actually contribute consuming some similar data than the one we've been using in the pipeline. Hazam, the floor is yours. You're muted.
Yeah, I got it. Thank you, Vivi. So yeah, we've had a look already on how to execute our checks in the Databricks pipeline. So now let's have a look from the analyst side on the Soda Cloud and how we can analyze, collaborate, and visualize the data. And so if we head to the data sets in the same data source, I can also have access to see the data that was onboarded by Vivi's pipeline. And so if we head into one of the tables, again, we are presented with the KPIs and the historical run of some of our checks. Now I see here that we have a check that failed, which is a missing value check. Now, I already know that I can look at this at the record level for the failed rows, but as an analyst, I'm also a bit curious at what is happening in this column. And so I can head to the columns tab to begin consuming the profiling information, which is captured by Soda. If we head to the job satisfaction column, we can already see that there are missing columns as the fail check suggested. And if we click on the button below, we can get some descriptive statistics along with some visualizations that kind of explain the distribution of the numerical values in our columns. And so I can notice here that the minimum and maximum value of this column are 0 and 6. But in the definition of satisfaction in the survey that we handed out, the range was only between 1 and 5. And so I can notice here that we do have a data quality issue that needs to be addressed and added as a check into Soda. Now, instead of messaging Vivi directly and telling her about this issue, I can actually use the no-code interface to add a check directly into Soda UI. And so by adding the check here, you would get this friendly no-code interface where, similar to the Soda CL, you can define a variety of metrics. And so here I can check for missing values, duplicates. I can monitor the row count and schema evolution of my data. And if I'm feeling a bit creative, I can also write a custom query using SQL and then raise a condition which will act as a check based on the output of this query. Now, for the example here, I would need to write a validity check. And so this validity check would be related to the range of satisfaction. And we would assign the column and then the rule. And in this case, the rule would be a maximum value of 5 and a minimum value of 1. Next, we can choose the conditions at which this check would alert or fail. And in this case, it would be a fail condition when there are any counts that violate this rule in our data. And finally, we can leverage the attributes again to add some tags to our checks. And for this case, for example, I can say that this check falls under the data quality dimension of validity. I can say that this belongs to the analyst team. From here, I have a few options. I can test the check to ensure that it executes correctly and already see the initial output of it. I can view the Soda CL to see how the syntax would look like in a YAML format. And finally, since I do not have permission to directly add checks to this data set, I can propose a check instead. And what this will do is it will open up a discussion, which is our collaborative environment where we can involve all of our stakeholders to define data quality checks. And so Vivi will get a notification that I have raised this discussion, and she will be able to review it and either approve it or through an iterative process, propose alternatives until we achieve a check that meets all of our needs. And so we see the check executed here quickly to show us what the value would be. And so it would be a failing check as expected. And we see Vivi has already gave an alternative proposal and with a comment saying that she changed the scan definition to include as part of her pipeline. And so if we review this check, we can see it's exactly the same thing as we defined earlier. The only difference is the scan definition here was changed from the default scan, which has a schedule, to the Databricks scan definition, which is triggered externally through the pipeline. Once I'm fine with this check, I can just tell Vivi that it's confirmed with her that this looks good and post it for her to finally add the check into our data set. Now, let's have a look at how we can visualize these checks. And so if we enter the dashboard here, we can see a visualization. Well, first we see some metrics of the checks failed, the checks weren't, and our data health score. But we also see some visuals of the ratio of checks to overall checks, passing and failing checks to overall checks. But what we can also do here is use the attributes again to filter our data based on what we would like to see. And so, for example, if I would like to see the data product that is in my team, the data analyst team, I would be able to see it. At the moment, there is not much there, but that is because I just added to the team at the moment. But otherwise, if we want to export this data to your own BI tool, you can make use of the Soda Cloud API, which exports the reporting layer and pushes this to a data warehouse of your choice. And so this data warehouse, then you can query this data to create your own customized dashboards like we have here in Databricks. And so you can see with just a glance, we are able to keep track of all of our defined data quality metrics, as well as a time evolution of our health status. This can be very configurable and it can integrate with any business intelligence tool. And by leveraging the attributes, once again, you're able to subset your data based on relevancy. And so with just a click, you're basically looking exactly at what you need to. And so as we wrap up, let's quickly recap on some of the key takeaways from today's session. Firstly, we've seen the concept of shift left, where by identifying issues early in your pipeline, you can catch problems before they propagate and affect our entire workflow. Secondly, we saw how we can use cross-team collaboration in Soda, which involves feedback from all stakeholders and ensures that data quality meets the needs of everyone involved and improves the overall results. And finally, we saw automated testing can significantly reduce manual effort, which allows us to utilize our resources and focus more on high-level tasks while ensuring consistency and reliability of our data. So with these principles in mind, you can maintain high-quality data standards, streamline processes, and improve overall collaboration across teams. Thank you. And we should be ready to take questions in a moment.
Fantastic. Thank you both, Hazem and Vivi. That was absolutely brilliant to see. We are now open for questions, if there are any. We may have presented so excellently that there was nothing left to be asked from our audience. So we'll give everyone a few minutes to post that through, as we have a few minutes left for the session. Whilst we do that, I'll just share some of those next steps that each of you can take, whether you're currently using Soda or new to Soda. Our Slack community is a brilliant place to join practitioners and peers and the Soda team to ask any questions, understand how other teams, how other engineers and analysts like Vivi and Hazem are putting Soda to use across their pipelines and to improve their data operations workflows. Our sales team are always available to answer any questions and also facilitate any customized demos that is relevant to your business requirements. So do get in touch. And lastly, it's hands-on, it's easy to get started, and it's ready. So access docs.soda.io, which will give you access to the use case that Vivi and Hazem walked through today, as well as many other use cases and explanations around Soda's integrations, getting started, and being successful. I see we have a question that has come in from Hector. Is it possible to view all Databricks and in brackets Unity catalog tables through Soda to create data quality rules?
Yes, I guess I can actually take that. So basically, you're configuring your data source, right? So you pass information for a specific schema. And then once you have configured your data source in such a way, you can decide in your Discover tab, as well as in the profiling configuration, which data sets you would like to onboard within Soda Cloud. Once you do show, all of those tables are actually going to be visible within the cloud. So also people that don't really have access in the underlying environment or Databricks necessarily, they can actually be able to perform checks on top of those tables the same way that Hazem showed already in the webinar.
Fantastic. Thank you, Vivi.
No worries.
No further questions. All right. With just a few minutes left, you know where to find us. We'd love for you to explore Soda and see what advantages it can bring to your Databricks platform and be part of our growing community. Thank you to everyone for joining our session today. It was a pleasure to host you. It was a pleasure to have you online, and we look forward to seeing you again soon. Vivi, Hazem, thank you for your fantastic presentation.
Thank you so much. Thanks
Thank you,
everyone for
everyone.
participating.
Take care, everybody. Thank you.